Hi there. Thanks for joining us. This is a Q&A edition of Space Nuts. My name is Andrew Dunkley. Coming up, we're going to be telling Pete the answer to his question about space junk. I think we kind of talked about that a bit in the previous episode. Philip wants to know about gravity waves. Diego is asking about matter. And Beverly wants to talk about seeing an eclipse. That's all coming up on this Q&A edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And he's here again. It's like he never left. Professor Fred Watson, astronomer at large. Hello, Fred.
Hi, Andrew. Good to not see you today, since we're not seeing each other.
Yeah, we're flying blind because something's chewing up bandwidth, and we thought, well, if we just turn the cameras off, it might improve. But no. Technology, isn't it great? Now, Fred, we might as well get stuck straight into this. I've got a couple of text questions and a couple of audio questions. And being as clever as I am, I have completely lost the questions as we speak, which is very unusual for me. So I'm going to switch things around, and we will play an audio question first up from Philip.
Hello, Fred and Andrew. Philip McCrackpipe here, originally from Glasgow. I moved to Australia when I was a wee baby. Never lost the accent, though. Two things for today. Firstly, I wanted to give a big shout-out to Gilmore Space Agency, who are close to putting a rocket up the northern end of Australia. They are amazing, and I wish them all the best in their grand quest. Secondly, I get the idea that gravity works by masses attracting each other and exerting a pull like magnets do. But what the heck are gravity waves made of then? They can't be made of light photons that just push things around, can they? Is it possible, despite what Michelson and Morley discovered, that there is indeed some kind of matrix permeating every square micro-inch of the universe that has gravity waves flowing through it, just as waves on the ocean move through water until rising to dump swimmers on the heads at Bondi Beach? If I'm right, do you reckon I could have my Nobel Prize now? I'd be happy to share it with you, bonny lads. Hey, love the show. And why not just keep recording extra shows so we can be listening to you both a century from now? Cheers.
Philip, I love the accent, by the way. That sounds great. But 100 years worth of episodes, that'd take us a little bit of work, I reckon, Fred.
Yeah. That's what it feels like already, Andrew, I have to say.
Yes.
Never mind. A great question from Philip. And yes, lovely accent. I thought I detected a little bit of Highland in there as well as the Glasgow. But anyway, that's a different story.
You'd be in a better position to pick up on that than me.
Yeah. Highland Scottish has got a very distinctive sound to it, and there's just a few sounds in Philip's accent there made me wonder. Anyway, thank you very much for the question, though. And yes, Gilmore Space doing a great job. Gravitational waves, Philip, you're kind of on the money, really. Except that we no longer think of gravity as being forces between massive objects. That's what Newton thought, and it's actually very nearly the truth. Modelling it that way makes it, makes the calculations fit what we see in space generally very well. But there's difficulties which are what led Einstein back in 1915 to propose his general theory of relativity, which says that actually what's happening is a massive object distorts the space around it. And that distortion is what we feel as gravity. So here's the Earth sitting in space, a massive object. It's bending the space around it so that the space at your feet has a slightly different shape from the space at your head. And the effect of that is that you feel as though you're being pulled down. It's an extraordinarily different way of looking at things from Newton's, but it actually works very well. And in fact, we've never managed to find a flaw in the theory of general relativity. And it's because of that distortion of space that you can have gravity wave or gravitational waves. because space can distort. So it's not entirely rigid. It's billions of times more rigid than steel. It's actually incredibly rigid, but it's still malleable. It's still bendable by mass, and hence its ability to transmit waves. And so in that regard, what you're saying, Philip, is not too far from the truth. Yes, the Michelson-Morley experiment did show that there was no ether that would transmit light, because that would have shown up had the space been permeated by an ether. Then you would have been able to see changes in the speed of light, depending on which way the Earth was going in regard to which way the light is going. And those changes were never detected because they don't exist. And that's because the speed of light is an absolute constant that, doesn't need an ether to transmit. So the old idea of an ether has now become what we would perhaps refer to as the fabric of space, something which can actually bend. It is a matrix, as you put it, that doesn't fill space. It's not something in space. It just is space. And through that, gravitational waves can travel. It's quite esoteric stuff. And I think you're touching on some really deep questions here in terms of the physics that are involved. But suffice it to say that space does have a structure, and that it can change if you put mass in it.
A few weeks ago, we did discuss gravitational wave background in the universe. Is that akin to what Philip was talking about, or is that a completely different concept?
No, it's a consequence of what we're talking about. Yeah, that you've got the gravitational wave background is exactly as you described it, Andrew, in that lovely analogue that you presented of throwing a handful of pebbles into a pond. So you've got waves, every pebble has its own splash, and you've got all these waves, basically travelling across the surface of the pond. And that would be a background to if you threw a rock in after that, there'd be a very big splash and lots of big waves, which would be kind of superimposed on that background of lower level gravitational waves. And that's what the gravitational wave background is about.
Okay, yeah. I loved Philip's question, not only for the accent, but he's obviously been thinking hard about this particular situation, and it's it spawned some ideas that, he didn't miss the mark at all, really, did he?
No, Philip, your Nobel Prize is in the post. We'll be happy to share it with you too. Thank you.
Yes, absolutely. Your name can go first, Philip. Was your idea, and great to hear from you. And keep sending your questions in to us. I've got a text question. Fred. Hi, Fred and Andrew. As with all question submitters, I'm a great fan of the podcast. In recent weeks, there's been multiple mentions of space debris, and dealing with it is by burning it up through attempted re-entry to Earth's atmosphere. This may well deal with most of the larger physical pieces that could cause damage. However, presumably at least some of the component elements of the junk don't suddenly cease to exist. I'm wondering if burning up is really just another example of what I've heard Karl Kruszelnicki say. He was told in his early steel mill days, the solution to pollution is dilution. As you often say, space, even just our atmosphere, is really big, but are we kidding ourselves to call burning up the final solution? That's Pete from Mamong Point. I think Pete's sent questions in before. It is an interesting problem. It is subject to a lot of discussion globally, how we deal with space junk, and the people who send material into space are responsible for it these days. Geordie knows that.
Yes.
And and there are times where space junk comes back to Earth. It doesn't get burnt up completely. There was a famous case in the last year or so where a farmer down in the Southern Highlands of New South Wales found a piece of a SpaceX rocket, I think it was, on his property. There's been all sorts of bits and pieces popping up from time to time. It is a problem.
That's right. I think that was, if I remember rightly, it was parts of the service module of a Dragon capsule, if I remember rightly.
Oh, yeah, might have been,
right.
Yes.
But
correct.
then there was, not about roughly the same time, there was a huge fuel tank washed up on the beach in WA, which came from an Indian space launch. So that's where it was eventually traced back to. So yes, you're right, Andrew, that for the bigger objects that maybe weigh more than a few 100 kilograms, they often will not burn up completely in the atmosphere, and so you get debris falling to Earth. And most of that is controlled. It's you can sort of control where the spacecraft is going to hit the atmosphere, where the burnup will take place, and where any debris might fall. And there is a particular spot in the Pacific Ocean, the South Pacific Ocean, which it's got a name which I can't remember at the moment, but it's the furthest point from land anywhere on the planet. And at the bottom of that ocean, it's a very deep part of the Pacific Ocean. There's a lot of space debris, because that's where you try if you've got something that is massive, and there is a risk that it will not all burn up in the atmosphere. That's where you want to put it, so that you're far away as possible from any likely damage. So that's one part of the problem. But I think what Pete's question is really aimed at is the stuff that does burn up, and for small satellites like a Starlink satellite, which is, yes, it's 1/4 of a ton, but it's still relatively small, that will burn up completely in the atmosphere. And what happens is the materials of which it's made are vaporized, and they do hang around. And I think we covered a story probably a few weeks ago, maybe a few months ago, that basically amounted to the fact that atomic species have been detected in the upper atmosphere, which can only have come from the material of spacecraft. So what it's saying is that, yes, the solution to pollution is dilution, but that dilution of the debris by being burned up and turned into vapor, that's not a process that means it disappears. There's still evidence of stuff being around up there in the upper atmosphere, and it's now in an atomic form rather than a solid object, but we can still detect it. So it's a good question that Pete raises. Yep, when we are, to some extent, polluting the upper atmosphere by the amount of re-entering debris.
Well, the alternative is to just shoot it off into oblivion, I suppose. But that's probably not as easy as it sounds.
That's right, because then you've got to reach the escape velocity of the Earth. That's 11 kilometers per second. What they do at geostationary orbits. So these are the orbits of the geostationary satellites, 36,000 kilometers above the surface. When they are no longer being used and regarded as a potential danger to other geostationary satellites, they put them into what are called graveyard orbits. And these are orbits that are pretty stable, but a long way out of the way. So it's doing exactly what you just suggested, shooting them off into oblivion. You're putting them in an orbit that where it's in orbit around the Earth, but it's not going to do any damage down the track.
And I think that place in the Pacific that you were referring to is Point Nemo.
Okay.
Which is 2,688 kilometres from the nearest land, and it's the furthest point from anywhere in the world in terms of solid land. It's at 48 degrees, 52.6 minutes south, 123 degrees, 23.6 minutes west, if you want to pinpoint it. Nearest land is Dulce Island, which is part of the Pitcairn Group, apparently.
There you go.
Yeah, so if you need to go looking for space junk, that's the spot.
It is.
All right. Thank you, Pete. Love the question. And yes, the problem of space junk continues. This is Space Nuts, not Space Junks, with Andrew Dunkley and Professor Fred Watson. Let's take a quick break from the show to tell you about our sponsor, NordVPN. And a virtual private network is something that a lot of people use these days to protect what they're doing online from scammers and hackers and anybody else who wants to download your information and sell it on the dark web, which has become all too common. There's a story recently about millions of people who bought tickets online having all their data now available for sale on the dark web. It's pretty terrifying stuff, isn't it? Of course, identity theft is another big reason that people get hacked, and it just goes on and on and on. So how do you protect yourself? Well, the first line of defense is a virtual private network, and there is none better than our sponsor NordVPN. And as a Space Nuts listener, there's an exclusive and special deal for you, including a 30-day money-back guarantee and an extra 4 months just for signing up. That's 4 months extra for a 2-year deal, 3 months extra for a 1-year deal, or you can go month by month. So all you have to do is go to the URL that's been set up for you, nordvpn.com/spacenuts. That'll bring you to an introduction page where you can click on a button that says Get the Deal. And once you're in there, you can look at all the products that are available, not just the virtual private network, but the other products, depending on what level you want to go. Now, if you want to stick to the basic service, that's fine. You can get high-speed VPN, and you can secure 10 devices at once. 10. So they've upped the ante on that. And you can then increase what you consider to be useful to you under the different packages that are available. I've got everything. My favourite of all is the cross-platform password manager. This is a really great product, and I've talked about it many times. And it's basically a way of storing all your usernames and passwords for all the online things that you need to get into, from your bank accounts to your email accounts to the password on your doorbell or whatever it is. You can do it all, and all you have to remember is the master password, one password to get you into the password manager, and then you can find what you want. And if you set it up properly, you can also log into all your respective web pages and bank accounts and all that kind of jazz straight through the password manager. Very, very clever, very simple, very useful. And let's face it, we've got so many user names and passwords these days, it's pretty well impossible to remember them all. What a lot of people do is use one password for everything. Not a good idea. But you can find out more at this URL, nordvpn.com/spacenuts. Check out their prices, check out their packages, check out what you need, and go accordingly, because the longer you sign up for, the lower the price gets on a monthly basis. But very much worthwhile, and an extra 4 months on top of whatever package you buy over whatever time frame. So a great deal for Space Nuts listeners. nordvpn.com/spacenuts. Have a look today and get the deal. Now back to the show.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Now, Fred, another text question. Hello, Fred and Andrew. This is Giergo from Slovakia. My question is about the matter we have in our universe. If I understand it correctly, all the matter we have is with us since the Big Bang, but energy can be converted to matter, and with the expansion of the universe, new energy, vacuum energy, is being added to our universe. Could this vacuum energy be converted into matter, thus creating matter that has not been with us from the very beginning? Thank you in advance for your longer version of no. Love your show. Giergo.
Oh, I love that.
At least he's confident.
Maybe let's modify it slightly and make it perhaps, or perhaps not. So we have talked before about the process of converting energy into matter. We commonly convert matter into energy. That's what happens in nuclear reactors. You're turning the mass of your uranium fuel or whatever it is directly into energy without needing it to go through other processes, chemical processes, for example. And so that's where that equivalence comes from. E equals mc squared. The two are equivalent. There are only a few natural processes, and we did talk about them. I can't remember what they were, that work the other way. And I think they only occur in very high intensity energy situations. By working the other way, I mean converting energy directly into matter. There are a few examples of it, but I can't remember what they are. We did cover it, and I remember reading up about it. So, the idea of the vacuum energy, the dark energy, as we also call it, turning into something solid is quite frightening, actually. Space is getting more and more rarefied, and so the vacuum energy is not in any sense in a high energy situation where you might get this process of energy being directly converted into matter. But it is an interesting question. So I hope that's a long enough version of no go.
Yeah, I think back in the 60s, Fred, they looked into this problem of dark energy turning into matter and decided that the only thing that dark energy could turn into was a rolling pin. So usually in a domestic environment.
Yeah, oh, that's real. That's black energy, isn't it?
Yeah, very dangerous topic too. That
Indeed
one.
It is.
Yeah, so Gergo, the answer is no-ish. No.
Great question, there. Thank you very much.
It was a good question. And one more quick one to finish off. This is a little bit behind the times, but only because of me having to find files that got ditched by my computer without my permission. It happens. This is Beverly.
Hello, Space Nuts. This is Beverly from College Station, Texas. I hope to be seeing my first total solar eclipse very soon, and I'm beyond excited. I was wondering if either or both of you had seen a total solar eclipse and would mind sharing your experiences and maybe your thoughts, your feelings about seeing that eclipse and any insight you have. I really appreciate your podcast, and I listen to it in the mornings when I walk. Thank you so much. Have a great day.
Thank you, Beverly. Lovely question. I threw that one in, Fred, because I wanted to see if you could figure out how many you've actually witnessed, because I know you've seen a few. I haven't, in person, ever witnessed one. Never.
Well, you should come with us on one of our eclipse tours. Actually, you are going to see one in 2028. So
yes, indeed,
right over your house.
Exactly. I don't have to go anywhere. I just have to wait. But how many have you seen, Fred?
I think the April 8th eclipse, which is the one Beverly's talking about, she was before April 8th when she recorded that. I think that was the 6th. In fact, I'm sure it was the 6th. One of them, just one, was clouded out, and that was the one in the Faroe Islands where they get 200 days of rain per year, and so we weren't expecting big events. I did see just a little bit of the eclipse phenomena. I saw something called Bailey's Beads, which is where the sun's disk shines through the valleys between the mountains of the moon. So I did see that through binoculars, but it wasn't a crystal clear experience. The one in Texas, we were probably not that far from Beverly. We were in a little village called, I think it was Bristol, a British name, but it's not very far from Fort Worth and Dallas. So we had a cloudy morning there, and the eclipse was sort of round about the middle of the day. Marnie had forecast, she'd looked at all the best forecasts that said the sky will clear in time for the eclipse. And during the period when you're leading up to the total eclipse, which is as the moon's disk gradually covers the disk of the sun, it's an extraordinary time. It's sort of building tension, and it's just like, it's like a live show, Andrew, done by the very best impresarios, where you build up people's excitement, and then there's a climax of a few minutes of the sun being blacked out completely. During that period when the moon was gradually crossing the disk of the sun, we were seeing quite a lot of it through holes in the cloud, but it was still basically cloudy. And then seconds before totality, the the sky completely cleared. It just cleared totally. And we had the most perfect view of the total eclipse that you could expect. And then throughout the afternoon, it was clear. It was sensational. And just turning to what Beverly's asked about, the emotional thing, it is almost a spiritual experience, if I can put it that way, Andrew, where you recognize that something deep and profound is happening. You've got this exact alignment between your spot on the Earth, and it's not there for everybody. It's only where the moon's shadow passes across the Earth, and the moon's shadow is only typically 100 kilometers or so wide. You've got that alignment between your spot on the Earth, the moon itself, and the sun. And it's the geometry of that it just somehow breathtaking, that it gives you this unique experience of a black disk surrounded by the corona of the sun. And sometimes, as we saw on the 8th of April, prominences, pink dots around the edge of the sun, which are clouds of glowing hydrogen. So it is, yes, it's quite awe-inspiring. People burst into tears. There's so much emotion tied to it, and part of that is just the build-up as the thing gradually takes place, and you see all these interesting phenomena as the sky gets darker. You see things called shadow bands, which are little bands of shade that race across the surface of the Earth, caused by turbulence in the upper atmosphere. It's a whole array of different phenomena that are well worth watching for. So yes,
and very, very, very rare indeed. The next total solar eclipse is the 12th of August 2026, which will start. It's basically up in the northern Arctic region, and then we'll move down across the Atlantic into southern Europe, by the look of it. And then the next one is the 2027 August, and then ours in 2028, the 22nd of July. In fact, I'm just looking at the future map for total eclipses, Fred, and this is an interesting phenomenon. There'll be two in a row that will cross continental Australia, and they will actually intersect around about southwest Queensland, northwest New South Wales, and probably northeast South Australia. So that particular spot will get two in a row in 2028 and 2030, which will be very exciting. That'll be the place to go.
There's actually five. If you, I think there's four more. If you include the one on the 23rd of April last year, which just touched the coast at Exmouth in Western Australia, including that one, there are five coming up in the next 20 years or so, I think, up to 2035. So you're quite right. And they are really interesting. Their paths do cross in an unusual way that is related to the sort of cycles that determine how eclipses work. Because, everything in the solar system is cyclic. Things are going around each other. So they do repeat in a sort of complex way. The one in 2027...
Sorry, the one in 2027 will intersect with the one in 2034. So there'll be another place where you can go to the same place twice. But I found the interesting one that also the 2027 eclipse will end where the 2028 eclipse will begin. Well, that was interesting.
Yeah, and it is a cyclic phenomena. We're going to be in Gibraltar for the 2026 eclipse, I believe.
Nice.
Southern tip of Spain. If you're interested,
yes, that could be the go. Yeah, I can see that one on the screen here. That one's going to stretch out over the Arctic and then move down through the Atlantic Ocean, by the look of it, or that area anyway. But a lot of them do start in the ocean, but that's just because 75% of the surface is ocean. I suppose it's just the way it works out.
Exactly.
But Beverly, I hope you got great joy out of witnessing your eclipse. I'm still waiting for my first one, so you're one ahead of me. And don't forget to keep sending your questions in. You can do that via our website, spacenutspodcast.com or spacenuts.io. You can send text and audio questions via the AMA tab up the top. And on the right-hand side, you'll see a little green sideways button that says send us your questions. If you hover over that, it turns purple. It's extraordinary. Never seen that before. exciting. I'm easily amused. But yes, don't forget to tell us who you are or where you're from. If you've got a device with a microphone, you're all set. And don't forget to subscribe to us on YouTube and to send in your reviews via your favourite podcasting platform. Fred, we are done. Thank you so much.
Great pleasure, Andrew. Always good to chat. And thanks for all the questions, everybody. Yeah, wonderful.
Yeah, it's fabulous. We'll talk to you soon, Fred. Fred Watson, astronomer at large, and Hugh in the studio is doing what he does best, and I don't know what that is. But thanks anyway, Hugh. And from me, Andrew Dunkley, thanks for your company on this episode. Catch you on the next episode of Space Nuts soon. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.